Have you at any time reviewed whether we're genuinely alone in the universe or, on the other hand, assumed there's something different to our reality other than whatever we see? Imagine what is going on. Consider the possibility that the James Webb Space Telescope at last shows that we live inside a black hole. Join us as we figure out more about this world and bring you news that will make you question all that you assumed you knew about the universe. So, what precisely are black holes? They're similar to something out of a spine-chilling thriller. Sure, you may have seen them in science fiction films, but what's much more upsetting is that they're not just a fictitious concept. According to well-informed specialists, black holes in space are actually huge amounts of matter packed into an inconceivably minuscule region. Imagine a star a few times more gigantic than the Sun, all packed into a space the size of New York City. The gravitational pull is so extreme that nothing, not even light, can escape from it. Researchers have been entranced by black holes for quite a while. At first, they studied objects in space so large and dense that they could trap light. The most striking ideas about black holes were proposed by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overpowers everything else, leading to the formation of a black hole. It is not easy to identify black holes as they emit no light. However, researchers have found ways to interpret their presence by noticing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull matter toward it in a process called accretion. Furthermore, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can consume nearby stars, produce intense light emissions, and even affect the formation of new stars in some regions while suppressing it in others. So, how do black holes form? Picture this. Stars once bright and shining meet their searing end in a massive explosion called a supernova. From the remnants of these fallen giants, black holes arise. Most black holes form from massive stars that have reached the end of their life cycle in a supernova. However, smaller stars, when they die, turn into something many refer to as neutron stars, which are incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it implodes under its own gravitational force, forming a black hole. As these massive stars collapse, something surprising happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the last defining point for anything falling into a black hole. The clock ticks at a different speed compared to ours. At times, when two smaller black holes collide, they merge to form a much larger and even more terrifying black hole. If a black hole interacts with a neutron star, it creates an incredible nightmare that resists understanding. Researchers have been wrestling with the size of these astronomical phenomena for a long time. Black holes come in two sizes, large and small. However, there's a bit of a misconception about them. Small is relative when it comes to black holes. Extremely large black holes, remnants of massive stars, can be as much as 10 million times the mass of the Sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That's a tremendous number of black holes that could swallow anything in their way. But wait, there's more. Very large black holes exist at the extreme end of the spectrum. They are millions, if not billions, of times greater than the Sun. These live at the centers of large galaxies, including our own Milky Way. They appear like a massive dead space, pulling everything toward them. The prestigious physicist Stephen Hawking talked about black holes throughout his life. His theories were well established, but some of his ideas proved challenging to confirm due to a lack of cutting-edge technology. Yet now there's hope on the horizon. Not too far off, a single revolutionary instrument is changing everything. It's known as the James Webb Space Telescope, JWST, and it's here to explore the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a demonstration of human ingenuity. Sure, we've launched other space telescopes before, and they've done their job well, but this rare machine is on a level that is truly extraordinary. The JWST makes the Hubble, which has served us for so long, look like a basic tool in the universe. The retail cost of this cosmic wonder is an astounding $1 billion. Yes, you heard that right, an eye-watering number of zeros. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this marvel to life, along with massive contributions from over 300 universities. However, we shouldn't forget the risks that come with such a monumental undertaking. I understand this isn't an endeavor for the faint of heart. The JWST is venturing into an unknown world, stretching the boundaries of what we know, and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last several times its original mission life. Since its launch, the JWST has already made several groundbreaking achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will reside indefinitely. During its journey, the telescope successfully deployed its enormous 5-layer sunshield and large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after calibration and adjustments, the telescope is almost ready for full operation. One of the most exciting parts of the JWST mission was when NASA announced it had captured its first major pictures of starlight. The first image taken by the telescope was of a star called HD 8446, revealing a series of 18 scattered bright spots from the star's light collected by the 18 mirror segments arranged on the primary mirror. NASA later released another stunning image of HD 8446, where 18 unfocused copies of the star were arranged in a deliberate hexagonal pattern. Once the observatory adjusts the individual areas of the primary mirror, it will begin the process of stacking images on top of each other to create one clear view. Thanks to its sophisticated technology, the JWST will assist scientists in studying the early stages of the universe following the Big Bang. It will focus on what happened after the first stars formed, a time known as the epoch of reionization. This refers to when neutral hydrogen was reionized, given an electric charge once again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help scientists discover exoplanets, which are extremely challenging to detect due to how they interact with their host stars. Strong observations can now closely study these planets, allowing scientists to examine their atmospheres and investigate the conditions necessary for life. The JWST capabilities will help researchers better predict whether specific planets might be habitable. Beyond studying planet formation, researchers focus on these worlds to understand how matter is organized on a massive scale. This, in turn, helps us understand how the universe has evolved, forming the galaxies we see today, billions of years later. One of the JWST goals is to look back at the earliest galaxies to better understand how they evolved. Scientists are also trying to determine how we got the variety of galaxies we see today, as well as the ongoing processes that lead to the formation and merging of galaxies. Ultimately, the James Webb Space Telescope will help us answer the most fundamental questions of all. Are we alone in the universe? Are we living inside a black hole? The JWST has already been on the hunt. And guess what? It has found compounds called polycyclic aromatic hydrocarbons, PAHs, hiding around massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures appear to be the goths of the universe. They're found everywhere, from distant galaxies to comets in our own solar system. Now, they're not just interesting because they could form the building blocks of life, but also because they help science track star development. When bright radiation hits these PAHs, they become energized and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument. This is often a sign that there are some hot, energetic stars nearby. But hold on for the surprising twist. Astrophysicist Ismael Garcia Bernard from Oxford University decided to examine 3 intriguing galaxies, NGC 6502, NGC 731, and the Stephan Quintet, as well as NGC 749. These galaxies are millions of light-years away in the depths of darkness. What Garcia Bernard found will send chills down your spine. In those central regions, where the black holes reign, he noticed an overflow of PAHs. Sounds interesting, right? Well, here's where it gets chilling. The radiation near these massive black holes changed the structure of the PAHs, transforming them into larger electrically neutral forms of themselves. The smaller electrically charged PAHs disappeared into nothingness, being consumed by the very darkness. However, the larger PAHs survived, finding shelter inside thin, dense gas clouds. It's as though they found their own protective cover against the fury of the black hole's pull. Now, you might ask why this matters. Well, for space scientists who rely on PAHs to trace star formation, it's a big deal. Star-forming regions may look like active black hole regions, but the rate of energy they give off is entirely different. PAHs act like markers. The fact that we found these compounds at the heart of galaxies around black holes is a massive clue to how stars evolve. We're looking for other worlds, other forms of life, and other black holes. Will the JWST uncover the greatest secrets in space? Stay tuned, because the universe is about to get a lot more interesting. The James Webb Space Telescope, JWST, is continuing its mission to unlock the deepest mysteries of the universe, and its discoveries are shaping a new era in astronomy. One of the most exciting possibilities is that it may finally offer insights into the nature of dark matter and dark energy, two of the most puzzling and elusive aspects of the cosmos. While we know that these forces make up the vast majority of the universe, we have little to no understanding of what they truly are. The JWST could provide new clues by observing the faintest and farthest objects in the universe, shedding light on how these mysterious forces influence the formation of galaxies, stars, and the overall structure of the cosmos. Beyond this, the telescope's ability to study the atmospheres of distant exoplanets is groundbreaking. By analyzing the light passing through their atmospheres, scientists can detect the chemical composition of these worlds, potentially identifying signs of habitability or even life. This could lead to the discovery of planets that are not only Earth-like but possibly home to conditions that support life. The JWST's sensitivity to infrared light allows it to peer through cosmic dust clouds that block other telescopes, revealing previously hidden details about planets and stars. The JWST also aims to solve long-standing puzzles about the formation of the first galaxies after the Big Bang. These ancient galaxies formed just a few 100 million years after the universe's birth, and understanding how they evolved could provide crucial insights into the origins of everything we know today. With its unparalleled imaging capabilities, the telescope will be able to capture images of these distant galaxies in exquisite detail, offering a window into a time when the universe was still young and chaotic. Despite the vast potential of the JWST, there are still challenges to overcome. The telescope's location, over 1 million miles from Earth, means that repairing it or making adjustments is practically impossible. This makes the success of its mission heavily dependent on the precision of its design and construction. However, the successes so far have been promising, and as scientists continue to calibrate and utilize the telescope's instruments, it is likely to provide us with answers to questions we've been asking for centuries. As the JWST embarks on its mission, we stand at the brink of a new era in space exploration. With each new discovery, we gain a deeper understanding of the universe's origins, its structure, and its future. From the enigmatic black holes lurking at the centers of galaxies to the distant exoplanets that could hold the keys to extraterrestrial life, the potential of the JWST is limitless. But perhaps the most profound discovery it could make is one that changes our perception of our place in the cosmos. As we peer deeper into the universe, we might find that we are not as alone as we once thought, or that the universe itself holds secrets far beyond our wildest imagination. In the end, whether we are living inside a black hole or not, the journey of discovery that the JWST offers will continue to challenge our understanding of the universe and our place within it. Each new piece of data from the telescope takes us one step closer to answering some of the most fundamental questions about space, time, and existence. And as we explore these cosmic mysteries, we are reminded of the infinite possibilities that lie beyond the stars. The James Webb Space Telescope, JWST, is not just a tool for observing the far reaches of the cosmos. It's a monumental leap in our ability to understand the very fabric of space-time itself. With its ability to observe infrared wavelengths, the JWST is able to peer through clouds of cosmic dust, revealing hidden stars, galaxies, and even entire star-forming regions. This capability opens up new avenues for exploring some of the most remote and earliest parts of the universe. One of the primary goals of the JWST is to explore the epoch of reionization, a time when the first stars and galaxies formed, reshaping the universe and making it transparent to light for the first time. Understanding this era could provide crucial insights into how matter and energy were distributed in the early universe. By studying the first galaxies that formed after the Big Bang, scientists can begin to unravel the mysteries of galaxy evolution. How did the first stars ignite? What mechanisms allowed galaxies to grow and evolve into the complex structures we observe today? The JWST is poised to answer these questions by capturing high-resolution images of the most distant galaxies, some of which may be so far away that their light has traveled billions of years to reach us. These observations could help refine our models of galaxy formation, offering a better understanding of how our own Milky Way and other galaxies came to be. The JWST's ability to study the chemical composition of distant objects also makes it a powerful tool for investigating the potential for life beyond Earth. By analyzing the atmospheres of exoplanets, the telescope can detect trace gases such as methane, oxygen, and carbon dioxide, which are often associated with biological activity. These findings could bring us closer to answering one of humanity's oldest questions. Are we alone in the universe? In addition to finding signs of life, the JWST can also investigate the conditions necessary for habitability. Understanding the factors that make a planet suitable for life could help identify worlds where life might have emerged, or may still be possible. The telescope's capabilities also extend to studying the enigmatic dark matter and dark energy that dominate the universe. Though invisible, these forces are thought to make up about 95% of the universe's total mass and energy. While their exact nature remains a mystery, the JWST's precise measurements of cosmic structures may help reveal clues about their influence on galaxy formation and the expansion of the universe. In the quest for knowledge, the JWST stands as one of humanity's most ambitious achievements, pushing the boundaries of science and technology. As it continues to explore the far reaches of space, it will likely uncover new phenomena and cosmic events that we cannot yet even imagine. The discoveries made by the JWST will shape our understanding of the universe for generations to come, offering us a deeper connection to the cosmos and perhaps a glimpse into the profound mysteries that lie ahead.